Welcome back to second year organic chemistry. So we were studying the methods of preparations of these alcohols. Okay. So let us continue with some more methods for the preparation of the alcohols. Next one, from esters. From esters. Esters can be subjected to hydrolysis in alkaline medium. For example, sodium or potassium hydroxide. This type of reactions are named as the saponification reactions. Saponification. For example, when you take an ester like RCOO R-, when this is subjected to hydrolysis by using sodium hydroxide, the carboxylic ester is converted to corresponding sodium salt and this R- group is converted to corresponding alcohol. Since this sodium salt of the carboxylic acid is named as the soap, the reaction is named as the saponification reaction. This is alcohol. Let us consider, for example, CH3, COO, C2H5. When ethyl acetate is reacted with sodium hydroxide, it gives rise to sodium salt of acetic acid, sodium acetate, along with the formation of C2H5OH. This is a similar method for the manufacture of the glycerol on the large scale. When oils and fats, they are subjected to saponification reaction. If you take, for example, oil or fat is nothing but CH2OCOR, CHOCOR, CH2OCOR. These are called as the triglycerides. Triglycerides can be either fats or oils. Anyhow, this topic of fats and oils we will study in the later class in the biochemistry. There, if R contains only saturated group, aliphatic group, alkane group, alkyl groups, then they are named as the fats. If they contain some unsaturated groups also, then they are named as the oils. When these oils and fats are subjected to hydrolysis by using sodium hydroxide, then we get 3 molecules of RCOONA, that is nothing but soap, along with the formation of glycerol, CH2OH, CHOH and CH2OH. This is glycerol. So this is the method of manufacture of this soap as well as glycerol. The next method is from ethers. Ethers are the alkoxy alkenes. When we have an ether like ROR-, if both R and R- are similar groups, it is called as the simple ether. If R and R- are the different alkyl groups, then it is called as the mixed ethers. So when you take ROR-, subject this to hydrolysis, that is called hydrolysis. Then we get this ROH along with R-OH. As I told you, if it is a simple ether, we get only one alcohol. If it is a mixed ether, then we get mixture of alcohols. So this is by the hydrolysis of an ether. Then coming to the next method, from water gas. This is a particular method for the manufacture of methanol from water gas. Water gas is actually a mixture of CO and H2. When white hot coke, red hot coke or white hot coke is passed with the steam or treated with the steam, or steam is passed over white hot coke, then it gives rise to mixture of carbon monoxide and hydrogen, that is called as the water gas. This water gas is mixed with half its volume of the hydrogen. So here already volumes 2 are present, 1 volume of hydrogen is mixed. This mixture is passed over zinc oxide and chromium sesquioxide at about 573 Kelvin, about 300 degrees Celsius. Then the reduction of this carbon monoxide will take place to give rise to methanol. This is a particular method for the manufacture of the methanol. This is not coming under general methods. It is a particular method for the methanol. When a mixture of water gas and hydrogen is passed over zinc oxide and chromium sesquioxide at about 573 Kelvin, we get methanol. Then the next method is for ethyl alcohol, particularly for ethyl alcohol. This is from molasses. Molasses is actually the mother liquor left behind after the crystallization of the sugar from the sugarcane juice. When sugar is subjected to milling, it gives rise to juice, sugarcane juice. Sugarcane juice is subjected to crystallization for the sugar. Only 50% of the sugar is crystallized. Remaining 50% is present in this molasses. This molasses is then subjected to fermentation. Fermentation using yeast and dilute sulfuric acid. When the mixture of molasses, yeast and dilute sulfuric acid along with some amount of water is kept in a tank for about 2 to 3 days. When all the sugar present in the molasses will undergo fermentation. So sugar is actually containing this C12H22O11. This is nothing but sucrose. This is undergoing hydrolysis to give rise to C6H12O6 plus C6H12O6. One is glucose, the other one is fructose. When glucose and fructose, this is actually the reaction carried out or catalyzed by the enzyme invertase. Invertase enzyme as well as the zymase enzyme are present in the yeast plant. So this reaction will take about 2 to 3 days. Once this glucose and fructose are produced, this C6H12O6 is then acted by the enzyme zymase present in the yeast. It will give rise to 2 molecules of ethanol plus 2 CO2. So this is the dilute alcohol that we get. Dilute alcohol, say for example, it is about 10% dilute. This is actually named as the wash, also named as the wort, WORT wort. To prepare absolute alcohol from this one, it is then subjected to distillation. We get about 90% alcohol. 90% alcohol, which is named as the raw spirit. The remaining 10% of water will be present. Excess of water is evaporated. This is then subjected to further distillation when we get about 95.5% alcohol. This is called as the rectified spirit. Rectified spirit. This is actually industrial method for the manufacture of the alcohol. So this 95.5% alcohol cannot be further distilled, because even if you distill 1000 times, it will give only 95.5% alcohol. To get the 100% pure, that is called as the absolute alcohol. Absolute alcohol. This is 100%. To get this one, either it is mixed with calcium chloride, or by distilled with benzene. When benzene and the remaining water and some amount of alcohol, they are evaporated as the ternary mixture, leaving behind 100% alcohol. So this is a particular method for the manufacture of the ethyl alcohol on industry scale. In sugar industry, wherever there is a sugar industry, there will be molasses as a byproduct. So using this molasses as a byproduct, we can manufacture the absolute alcohol. So wherever there is a sugar industry, there is a industry which manufactures this alcohol. Then coming to the properties of these alcohols. Coming to the properties of the alcohols, first we will consider physical properties. All alcohols, lower alcohols, are physical properties. Lower alcohols are liquids. With characteristic smell. And causes burns in mouth. Or we can say has burning taste. That is the reason why the pure alcohol cannot be used as a drink. It is mixed with water or some other liquids to get the drink. Then coming to the second one, boiling points. When we have these boiling points, actually the lower alcohols are liquids, while higher alcohols are waxy liquids without smell. Then coming to the second property, boiling point. For these alcohols, boiling point increases with increase in molecular mass. For example, if you consider this methanol, it is having a lesser boiling point than ethanol, CH3, CH2OH. This is having lesser boiling point than propanol, like that. So as the number of carbon atoms increases, molecular mass increases, the boiling point also increases. That is the reason why the higher alcohols are waxy liquids. Then among isomeric alcohols, say for example, if the alcohols are having the same molecular mass and if they exhibit chain isomers or position isomers, etc., as the branching increases, boiling point decreases. Because as the branching increases, the surface area becomes smaller. As the surface area becomes smaller, attractive forces among the boiling points will decrease. Say for example, if you take this butanol, if you take one butanol, CH3, CH2, CH2, CH2OH, this is having a higher boiling point as compared to isobutanol or 2-butanol, because there is a branching here of the OH group, and this is having a higher boiling point than this CH3, CHOH, CH3, CH3. So as the branching increases, the boiling point decreases. And when you take the boiling points of these compounds, alcohols, comparing to alkanes and haloalkanes, boiling points of alcohols are higher. It is because of, or you can say due to, hydrogen bonding. Say for example, I am having an alcohol with this formula ROH. This hydrogen, I will write here hydrogen, and this has alkyl group. Since this hydrogen and oxygen bond is polar bond, hydrogen carries a slight positive and oxygen carries a slight negative charge. Since this is linked to oxygen atom of the other molecule, H plus and O, delta minus. This is R. Similarly, this links to another molecule like this, H plus O minus delta R. So this continues. Because of the extensive hydrogen bonding among the molecules of the alcohols, they have got higher boiling points as compared to the hydrocarbons and haloalkanes. And the same reason we can give for the next property, that is solubility. Lower alcohols are highly soluble in water. This is due to hydrogen bonding again. Hydrogen bonding between H2O and alcohol molecules. Hydrogen of water and O oxygen atom of the alcohol, they link by hydrogen bonding. Similarly, hydrogen of the alcohol and oxygen of the water molecule, they link by the hydrogen bonding. Because of these hydrogen bondings, the lower alcohols are highly soluble in water. When we say lower alcohols are highly soluble, the solubility will decrease with increase in the molecular mass. So, solubility decreases with increase in molecular mass. So, these are some physical properties for the alcohols. Most important as far as the various examinations are concerned, competitive examinations as well as board exams are concerned, the boiling points of the isomeric alcohols is most important. Among the various isomeric alcohols, as the branching increases, the surface area decreases and hence the boiling points will decrease. 1 butanol having higher boiling point than 2 butanol, higher boiling point than tertiary butyl alcohol. Okay, CH3 thrice COH. So this is what about the physical properties. We will consider the chemical reactions or properties of these alcohols in the next video. Thank you.